Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before, or even considered taking up programming. Today we will look at linear and non-linear programming, what they are and how do we use them. Relax, there are no mathematical formulas in this video. One of the things that can discourage people from taking up programming is that it can seem complex. Much of this complexity is down to the way you communicate with the computer. In other words, the interface between you and the machine. Part of this is the difference between linear and non-linear programming. Don't worry, this isn't anything to do with mathematics. Traditionally, we, as humans, have solved large complex problems by breaking them down into many smaller and much simpler problems, and then solving each of the simpler problems one at a time. This approach has worked from the time the pyramids were built right up until we landed on the moon. The approach is still valid today. Currently, many of these problems are solved with the computer code within applications or programs. Linear programming is the handling of tasks in a straight line. Task 1 is completed before Task 2 is started, and Task 3 is started after Task 2 has completed. Non-linear programming can involve multiple tasks all running at the same time. Each task, once started, will run quite independently from its parent task. In human terms, this could be described as a computer's ability to multitask when running a program. Much of this is made easier with modern programming languages, which do a great deal for you. In the early days of computers, just adding two numbers together and getting the right answer could be an adventure. So to illustrate what we have just spoken about, let's look at a linear program example. If we have an application which needs to read a file, process it and produce an output, then the first task could be to open the file and read the contents into memory. Task 2 could be to scan through that area of memory which holds the data and perform calculations upon it. And finally, Task 3 could be to produce a report file on the output of the calculations. So this is a straightforward, linear path through tasks 1, 2, and 3. Alternatively, if the file is very large, we may look at doing this series of tasks differently to speed up the processing. For example, Task 1, open the file and count the number of records. Task 2, launch a number of separate tasks to run concurrently. Each of these concurrent tasks will operate upon a section of the file and perform its calculations and save those to its own report file. These would be called threaded functions in PowerBasic. Task 3 would be to wait for all of these concurrent threads to complete. And finally, Task 4, read and combine all the report files from the threaded functions into one final report. As the calculation task is being performed by multiple independent functions, all running at the same time, then the processing time for a large file can be reduced considerably, limited only by the number of processing cores on your CPU. This is parallel processing, and some problems lend themselves to this approach, and some do not. When you are using the PowerBasic console compiler, most of the applications which you will create will be linear. Those which need to do parallel processing can use the inbuilt thread handling to make the application partially non-linear. Learning the console compiler commands first is recommended for beginners to programming, as most of the time you'll be doing linear programming. When you want to start using a graphical user interface in your application, you'll tend to use the PowerBasic Windows compiler. Let's look at the design of a simple form in the Windows compiler. The form will have a number of objects on it, which need to be created when the form loads. Each of these objects will have one or more events that can be triggered by the user. For example, entering text into a text box or clicking on a button. When the form is displayed to the user, there needs to be a process running in the application to monitor the objects and act as an event handler. This process in PowerBasic is known as the callback function. You can create a callback function for the entire form, or you can create a callback function for each object on the form. Personally, most of the time I create a callback function for the entire form, in order to keep all the code in one place. This is where our application starts to move towards non-linear, and this can sometimes be hard to grasp the concept for those just starting to learn to program. The application needs to watch for the user doing something, like triggering an event, for example, clicking on one of the buttons. Having clicked on the button, the background process could then run a great deal of code, all while the user is busy filling in boxes on other controls on the form. The perfect example of this is your mail client. Whether you use Outlook, Thunderbird, or some other mail application to handle your emails, they are all multitasking or threaded applications. While you are reading or writing an email, there will be processes running in the background, doing things like checking for new emails coming in, running rules on a mail coming in to move it to a specified folder, checking for spam emails, sending emails you are requested to send. All this goes on independently of what you, the user, is actually doing in the rest of the application. Hopefully, with this background, you'll have a better understanding of the differences between linear and non-linear programming. And as you start to use graphical user interfaces in the PowerBasic Windows compiler, you'll start to see the reason for non-linear programming. However, that's it for today. Thank you for watching.